Whoa, it's Ash, Ketchum, and Flareon. Ash encounters a shiny Flareon standing 25 meters away. If Ash can throw a Pokeball at 18.5 meters per second, what angle should he aim at to hit the Flareon? And theta is in between 45 degrees and 90 degrees.
Let's start with the horizontal motion equation because it's the most straightforward. We can substitute the horizontal velocity component for v0 cosine theta, and then isolate time. There isn't anything else we can do with this, so let's save it for later. Bringing in the vertical motion equation, we can immediately substitute vertical displacement for 0, because the height the ball leaves Ash's hand is just the same height it will hit Flareon. Vy0 is just v0 sine theta in shorthand. Also note that everybody brought time to the party. We are left with one time variable that we can move to the other side and then substitute using the horizontal equation we started with. Let's move both thetas to the same side so that we can combine them using the double angle sine formula. Now, we can take the inverse sign and divide by 2 to get a solution for theta, but not the solution we're looking for. 23 degrees would hit Flareon, but the angle is below 45 degrees, which is considered bad practice amongst Pokemon trainers. But don't worry, all hope is not lost. When we wrote that sine of 2 theta is equal to this value, about 0.716, it meant that there were 2 possible values for theta in the first 2 quadrants of the unit circle. The inverse sine function gave us a first quadrant solution, which is why theta 1 was less than 45 degrees. A second quadrant solution will give us a value of theta 2 between 45 and 90 degrees. Looking at the unit circle, 2 theta 2 equals the angle between 180 degrees and 2 theta 1. Dividing by 2, theta 2 is 90 minus theta 1. And if theta 1 was 23 degrees, then theta 2 must be 7 degrees. Let's try it out.
Whoa, the ball will hit Flareon. Question 2. The Pokeball has a density of 200 kilograms per meter squared and a radius of 2.5 centimeters. A Pokeball needs at least 2 newtons of force to activate. Will it catch Flareon?
So the first thing we notice is that the Pokeball is a projectile, so the only force on it is going to be the force of gravity. So our sum of forces from the y direction is just the force of gravity. That's the only force we have. We know that that's equal to mass times acceleration due to gravity, so our only unknown is mass. And we need to solve for mass in terms of density and radius. We know that density is equal to mass over volume. We can rearrange that equation to get mass equals density times volume. We know that the volume for a sphere, like the Pokeball, is 4/3 pi r cubed. So our force of gravity is going to come out 4/3 pi r cubed rho times g. We can plug in our values for g, for r, and for rho. That'll come out to 3.46 newtons for the force of gravity. So the Pokeball will hit the Flareon with an impact 3.46 newtons, greater than 2 newtons, so we will capture the Flareon.
Gotcha! Flareon was caught. Thanks for watching. Hooray!